Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I'm going to discuss a very interesting mathematical technique to solve problems like this. From a uniform disk of radius r, a circular portion of diameter r is removed. Find the position of center of mass, rather new position of center of mass. This method is known as negative mass method. It's very interesting. Consider a disk of mass m and radius r. It is a uniform disk. So mass per unit area, mass is distributed uniformly throughout the area. So mass per unit area or the surface mass density is constant. I'll represent the surface mass density of the disk with the symbol sigma. Now a cavity is made by removing a circular portion of diameter r. So as you see in the figure, there is a cavity of radius r by 2. I'll take the center of the disk to be origin to locate the center of mass. The mass is removed from the right of the origin. So now there is more amount of mass to the left of the origin. Certainly the center of mass should shift to the left of the origin. We'll try to locate the exact position of center of mass. In this negative mass method, we are going to interpret 0 as x minus x, which means that we are going to interpret this cavity. The mass of the cavity is 0. There is nothing inside the cavity. So this nothing, mathematically, I am interpreting as m1 minus m1, which means consider a disk of mass m1 in this region of cavity. On top of that, imagine another disk of mass minus m1 of a negative mass. So the total mass in this region would now sum up to 0, m1 minus m1, that is 0. So cavity can be interpreted as two disks, a positive mass disk and a negative mass disk. Practically there is nothing like negative mass, mass is always positive. This is just a mathematical interpretation of 0. So let us apply this here now. So I'll take a big disk of mass m. Mass of the disk is m, which is density into area of the bigger disk, that is sigma pi r square. And I'll take a small disk of mass m1 whose mass is negative. So negative of sigma, area of that smaller disk is pi into r by 2 whole square, which is pi r square by 4. And the coordinates of center of mass of the smaller disk are r by 2 comma 0. A disk with a cavity can be taken as two disks. One is a positive disk and another negative mass disk of radius r by 2 or diameter r. Now you know the coordinates of center of mass of two disks. You can find the x coordinate of center of mass of the system. The equation to find the center of mass's x coordinate is m1 x1 plus m2 x2 by m1 plus m2. Applying this, mass sigma pi r square into its x coordinate, which is 0, plus minus sigma pi r square by 4 into the x coordinate of center of mass is r by 2 by m plus m1, which is sigma pi r square minus sigma pi r square by 4. I'm solving this. The first term is 0 minus sigma pi r square by 4 into r by 2 by p by 4 of sigma pi r square. I can get rid of sigma pi r square by 4. I'm left out with minus r by 2 by 3, which is minus r by 6. And y coordinate of center of mass is evidently 0 because y coordinate of m as well as m1 both are 0. So y coordinate of center of mass of the system is 0. So finally we arrive at the center of mass of the system, which is nothing but the disk with a cavity having coordinates minus r by 6 comma 0. So the position of center of mass is to the left of the origin. This is center of mass. The coordinates are minus r by 6 comma 0, which means that after removing the mass from the disk, the center of mass has shifted to a distance of r by 6 to the left of origin. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.